Hello students. So today I am doing class 12 science. The topic is the same topic that we are doing the last online class. The topic is first order derivative. So this is your continuation class again. Okay. So first order derivative, exercise 3A. Each question carries 4 marks. Okay. So each question carries 4 marks out here. So now we will do find dy by dx. Each question carries 4 marks. That is page number 293. So find dy by dx when question number 6, that is question number 6, number 5. Let's do question number 5 now. Okay. So x is equal to sec inverse within bracket. What is given here? It is 1 plus t square divided by 1 minus t square, and y is equal to, this is tan inverse 3t minus t cube divided by 1 minus 3t square. Right? So this is the question. You have to get the value for dy by dx. Find dy by dx when 6 number 5, that is x is equal to sec inverse within bracket 1 plus t square upon 1 minus t square, and and y is equal to tan inverse within bracket 3t minus t cube divided by 1 minus 3t square. Okay. So here also you cannot differentiate it directly. So let us use the formula from inverse circular function or trigonometry. Right. So what is the first one here? So these are also the parametric equation. So here x and y are expressed in terms of a third variable t, that is t is a parameter here. So this is a parametric equation. So now how will you differentiate this parametric equation? You know it. Okay. So given x is equal to sec inverse within bracket 1 plus t square divided by 1 minus t square. So it will be easier for you to convert this sec inverse into cos inverse so that we can easily use the formula, right? So let us convert it into cos inverse. That is cos inverse 1 minus t square upon 1 plus t square, right? So here we put t is equal to tan theta. So let us use the trigonometric substitution. So what should we put for t so that we can have cos inverse cos 2 theta? So you should put t is equal to tan theta. So let t is equal to tan theta. So what is the value for theta in this case? It is tan inverse t. So therefore x is equal to cos inverse within bracket, it is 1 minus tan square theta divided by 1 plus tan square theta, right? So what is the value for x in this case? So x is equal to, what is the value here? Cos inverse within bracket. So cos inverse within bracket, what is 1 minus tan square theta upon 1 plus tan square theta? It is, you know that this is the formula for cos 2 theta. You know it from multiple angles. Okay. So or x is equal to, what is cos inverse cos 2 theta? It is only 2 theta. So what is the value for theta in this case? So x is equal to 2 into, what is theta? It is tan inverse t. So now you can differentiate it easily, isn't it? Right now, differentiating both the sides with respect to t. So this expression is simplified and we get x is equal to 2 tan inverse t. So it will be easier for you to differentiate this function, isn't it? So differentiating both the sides with respect to t. Differentiating both the sides with respect to t. Therefore, dx by dt is equal to 2 into, this is your 1 plus t square. So let us mark it number 1 because 2 is constant out here. So what is d by dt of tan inverse t? It is 1 upon 1 plus t square. Okay. So again what is the value for y? So again here y is equal to tan inverse within bracket 3t minus t cube divided by 1 minus 3t square. So here you can put also tan theta, t is equal to tan theta, but you put let t is equal to tan beta. Okay, so what is the value for beta here? It is tan inverse t. Therefore y is equal to tan inverse. So within bracket, what do we get? It is 3. Instead of t, you write tan beta minus tan cube beta divided by 1 minus 3 tan square beta. Bracket closed. Okay. So the formula for this expression will be tan 3 beta. Okay. Because you know that tan 3 beta is equal to 3 tan beta minus tan cube beta divided by 1 minus 3 tan square beta. So instead of this expression, you can write down the formula. That is y is equal to tan inverse. It is tan 3 beta. It is tan 3 beta. Right? So next. Now next. Therefore, y is equal to, what is tan inverse tan 3 beta? You know that it is only 3 beta. So it is 3 beta. Therefore, y is equal to 3 into, what is the value for beta in this case? It is tan inverse t. So it is tan inverse t, right? So now you can differentiate with respect to t. So differentiating both the sides with respect to t, right? So let us get the value for dy by dt now. Therefore, dy by dt is equal to 3 into 3 is constant, it is taken outside. So what is d by dt of tan inverse t? It is 1 upon 1 plus t square, right? So this is number 2. So now what will you do? Since you have to get the value for dy by dx, you can divide 2 by 1 or 1 by 2. Divide 2 by 1 because you should get dy by dx, isn't it? So dividing 2 by 1. So dividing 2 by 1. Therefore, what do we get dividing this 2 by 1? That is, you should write down left hand side of number 2 in the numerator. dy by dt divided by, write down left hand side of number 1 in the denominator. That is dx by dt. Is equal to, on the right hand side, write down right hand side of number 2 in the numerator. 3 into 1 upon 1 plus t square divided by, write down right hand side of number 1 in the denominator. That is 2 into 1 upon 1 plus t square, right? So here this will be cancelled 1 by 1. Here dt will be cancelled. So you will get dy by dx, which is equal to, the answer is, this is 3 by 2. So this is the final answer. So this question is very, very important, right? So we'll do the next question now. So now we'll do the next question, that is find dy by dx when this is 6 of number 6. X is equal to cos inverse within bracket 8t to the power 4 minus 8t square plus 1, and y is equal to sin inverse within bracket 3t minus 4t cube. So here also we should do trigonometric substitution. Then only it will be easier for you to find out dy by dx. Otherwise, if you do it directly, it will be complicated. You will not get the answer in the simplified form. But you should get the answer always in the simplified form. Okay, so this is very, very important question. This question is from HS 2015. Okay, and this question carries 4 marks, right? So let's do it. So here given is, so what is given here? X is equal to cos inverse within bracket 8t to the power 4 minus 8t square plus 1, right? So what should you put for t? That is, you should do the trigonometric substitution here. So what should you put for t? Whether it is sin theta or cos theta. You may put either sin theta or cos theta, right? So let us put t is equal to sin theta. Or what is the value for theta here? So theta is equal to sin inverse t. So what does it become now? X is equal to cos inverse within bracket 8 sin to the power 4 theta minus 8 sin square theta plus 1. Okay? So if you simplify it, you should get the form cos inverse cos theta form. You may not get cos theta. You may get cos 2 theta, you may get cos 3 theta, you may get cos 4 theta like that. Okay? So cos inverse cos theta form should be there. So let us simplify it. Okay? So let us write it in the rough part. Let's simplify it. In the exam also, you should do it in the same pace that we are doing. You should do it on the same pace. Okay? You should do it on the same pace in which you are doing the problem. Okay? So यो एउटा तिमीको के भयो एउटा exam paper भयो. Suppose this is your examination paper. Okay? त त्यो जुन चाहिँ प्रब्लम तिमीले गर्दैछ त्यसकै छेउपडी नै तिमीले रफ वर्क देखाउनु पर्छ. Okay? So let's do the rough work here. So let's do the rough work out here. Okay? Let us simplify the expression within bracket, that is 8 sine to the power 4 theta minus 8 sine square theta minus 8 sine square theta plus 1. Let us simplify it. Okay? So now, in this case, you can use the formula of 2 sine square theta. You should know the formula of 2 sine square theta from multiple angles. What is 2 sine square theta is equal to? It is 1 minus cos 2 theta, right? So let us simplify it, which is equal to. So now we are simplifying the expression within bracket here. Okay? So it is 2 into 4 sine to the power 4 theta minus 4 into within bracket you should write 2 sine square theta plus 1. That means we are expressing this term in terms of 2 sine square theta. So that's why it is written 2 into 4 sine to the power 4 theta. So 2 into it is 2 sine square theta whole square minus 4 into, now within bracket, what is the formula for 2 sine square theta? It is 1 minus cos 2 theta then plus 1, right? Is equal to 2 within bracket. Again, what is 2 sine square theta? It is 1 minus cos 2 theta whole square. Now multiply by minus sign here, minus 4. So it is minus 2 minus plus 4 cos 2 theta. Then this is your plus 1, right? So it's equal, let us simplify 2 within bracket. Now this is your a minus b whole square. What is the formula? What is a minus b whole square? A square minus 2ab plus b square. So write it here. 1 minus twice ab is 2 cos 2 theta plus what is b square? It is cos square 2 theta, right? Minus 4 plus 4 cos 2 theta then plus 1. So which is equal to, this is 2 1s are 2 minus this is 4 cos 2 theta plus 2 cos square 2 theta, right? Then minus 4 plus 1 is minus 3 and it is plus 4 cos 2 theta. Is that clear? Now we can cancel here. This 4 cos 2 theta, 4 cos 2 theta gets cancels, which is equal to, now write down 2 cos square 2 theta, then minus 3 plus 2 is different sign, you have to subtract, that is 1, but you have to write down the sign of the greater number, that is minus. Okay, so it is minus 1. Now again you should know this formula, that is if you have 2 cos square theta minus 1, then what is this formula? It is cos 2 theta, right? So 2 cos square theta minus 1 is equal to cos 2 theta. So if you have 2 cos square theta, only theta is there, then minus 1, then you can write cos twice theta. But here, instead of theta, what is here? 2 theta. So is equal to cos, what is the formula? 2 into 2 theta, which is equal to, what is the value here? That is cos 4 theta. That means, what is the simplified value of 8 sine to the power 4 theta minus 8 sine square theta plus 1? It is cos 4 theta. Is that clear to all of you? So this is just the trigonometric simplification. You could have done it in, you must have done it in class 11 also. In class 11 in multiple angles there is a problem there. Prove that 8 sine to the power 4 theta minus 8 sine square theta plus 1 is equal to cos 4 theta. Okay, so let us write it here. Therefore, x is equal to cos inverse within bracket cos 4 theta, right? So x is equal to, what is cos inverse cos 4 theta? That is your 4 theta. Is it clear to all of you? So you should show it in the rough work pace, right? So now in the next step, therefore x is equal to 4 into, what is the value for theta in this case? It is sine inverse t. That is, it is sine inverse t. So what is the simplified form of cos inverse within bracket 8t to the power 4 minus 8t square plus 1? It is 4 sine inverse t. Now you can easily differentiate this function, isn't it? So if you differentiate it directly, that is cos inverse 8t to the power 4 minus 8t square plus 1, it is complicated, right? You may not get the simplified answer here. But that is the easiest function to be differentiated, isn't it? So now, write down differentiating both the sides with respect to x. Differentiating both the sides with respect to x, right? So therefore dx by dt is equal to 4 is constant, it is kept as it is. What is the differentiation of sine inverse t? You know that it is 1 upon root over 1 minus t squared. That is number 1. Is that clear? That is your dx by dt. So we have got dx by dt is equal to 4 into 1 upon root over 1 minus t squared. That is number 1. So again next, y is given here. Y is equal to sine inverse 3t minus 4t cube. So how will you simplify it? Just you put t is equal to sine beta here. Don't put theta, sine theta. Let us put t is equal to sine beta. Because you know 3 sine beta minus 4 sine cube beta is sine 3 beta. That is, what is the formula for sine 3 theta? 3 sine theta minus 4 sine cube theta. Or you may put 3 sine beta minus 4 sine cube beta is equal to sine 3 beta. So let t is equal to sine beta. So what is the value for beta in this case? It is sine inverse t. Is that clear now? So we are putting t is equal to sine beta. Therefore, y is equal to sine inverse within bracket. So you write instead of t sine beta minus 4. What is t cube? It is sine cube beta. Is that clear? Next, what will you do? Y is equal to sine inverse within bracket. It is sine 3 beta. Its formula is 3 sine beta minus 4 sine cube beta is sine 3 beta, right? So therefore, what is y now? Y is equal to sine inverse sine 3 beta is equal to 3 beta. Therefore, y is equal to 3 into what is beta in this case? It is sine inverse t. So now you can easily differentiate that one, isn't it? So right now, differentiating both the sides with respect to t. Therefore, differentiating both the sides with respect to t. Therefore, dy by dt is equal to, again here 3 is constant, you have to keep it as it is, 3 into, what is d by dt of sine inverse t? It is 1 upon root over 1 minus t square. Let us mark it number 2. So now, how can you get the value for dy by dx? What will you do with this 2 and 1? To get dy by dx, you should divide. That is dividing 2 by 1. So you should write dividing 2 by 1. So now write down left hand side of number 2 in the numerator, that is dy by dx, because you should get dy by dx. So dy by dt should be written in the numerator. Divided by, write down right hand side, write down left hand side of number 1 in the denominator, that is dx by dt, which is equal to, on the right hand side, now write down right hand side of number 2 in the numerator, 3 into 1 upon root over 1 minus t square divided by, write down right hand side of number 1 in the denominator now, that is 4 into 1 upon root over 1 minus t square. Is that clear? So you can cancel it, these 2 will be cancelled, here dt gets cancels. So what is the simplified value of dy by dx is equal to, this is your 3 upon 4. So this is the final answer. So this question is very important. So this question is from HS 2015, right? So you can copy it. Now we'll do the next question now. So now we will do another type of question, that is question number 10. So this is different type of question is there. Find the differential coefficient of tan inverse divided by 1 plus tan inverse x with respect to tan inverse x. So in this case, the first function given here is tan inverse x upon 1 plus tan inverse x. You should assume it as y. And the second, with respect to tan inverse x, that is second term is given, you should assume it as z. That means this question becomes, if you assume it as y, if you assume it as z, this question becomes, find the differential coefficient of y with respect to z. Differential coefficient, differentiation and derivatives have got the same meaning. Okay? So this question now becomes, find the differential coefficient of y with respect to z. That means mathematically you have to get the value for dy by dz. Is that clear? So actually you have to find out dy by dz. So let us assume the first function as y and the second function as z. And you have to calculate dy by dz. Okay? So let y is equal to what? That is the first function, tan inverse x upon 1 plus tan inverse x. Right? And z is equal to what? And z is equal to tan inverse x. Now we have to find out the differential coefficient of y with respect to z. That means you have to calculate dy by dz. Okay? So it is just like your parametric equation. So the variables y and z are expressed in terms of a third variable x or the parameter x, and this equation is known as what? Parametric equation. So you have to calculate dy by dz from here. Okay? So here given is y is equal to tan inverse x divided by 1 plus tan inverse x. Let us differentiate it directly with respect to x. Okay? So differentiating both the sides with respect to x, right? So therefore dy by dx is equal to, which rule is used? U by v. Let us keep the denominator as it is. That is 1 plus tan inverse x is kept same. Now differentiate the numerator with respect to x. It is 1 upon 1 plus x square minus, again numerator is kept same. That is tan inverse x. Now differentiate the denominator and write it in the numerator. Tan inverse x into, what is the differentiation of 1? It is 0, you don't have to write it. Plus, what is the differentiation of tan inverse x? It is 1 upon 1 plus x square. This whole divided by what? Whole divided by what will you write? That is denominator whole square. That is 1 plus tan inverse x whole square. Is that clear to all of you? So, we are getting the value for dy by dx. So, therefore, dy by dx is equal to, now in the numerator, you can take common out here. So, what is common out here? It is 1 upon 1 plus x square. So, within bracket, what do we get? It is 1 plus tan inverse x minus tan inverse x, isn't it? It is 1 plus tan inverse x minus tan inverse x. Got it? So 1 upon 1 plus x square is taken common out here. So within bracket, what do we get? We get 1 plus tan inverse x minus tan inverse x. So divided by 1 plus tan inverse x whole square. Is that clear? So here you can cancel this tan inverse, so it is only 1. So what is 1 into 1 upon 1 plus x square? It is 1 upon 1 plus x square. So or it is dy by dx is equal to 1 upon, in the denominator, what should you write? So both these are in the denominator now. That is 1 plus x square into 1 plus tan inverse x whole square. So in this case, we get the value for dy by dx. Let us mark it equation number 1. Okay, let us mark it number 1. So now let us find out dz by dx. What is the another function? That is z is equal to tan inverse x. Again z is equal to tan inverse x. You can easily differentiate it by using the formula, isn't it? So right now, differentiating both the sides with respect to x. Differentiating both the sides with respect to x. Okay. So what is dz by dx? So dz by dx is equal to 1 upon 1 plus x square. Number 2. Now we should divide 1 by 2 to get dy by dz. Actually, you have to find out the differential coefficient of y with respect to z. के चाहिँ निकाल्नु पर्छ हामीले अब हामीले निकाल्नु पर्छ dy by dz निकाल्नु पर्छ. त्यो के गर्नु पर्छ dy by dz निकाल्नलाई यो 1 लाई 2 ले चाहिँ डिवाइड गर्नु पर्यो हैन. So let us divide 1 by 2 to get dy by dz. के गर्नु पर्छ नि यहाँ यो 1 लाई चाहिँ हामीले 2 ले के गर्नु पर्छ डिवाइड गर्नु पर्छ. ठीक छ. So dividing 1 by 2 So therefore अब यो 1 लाई हामीले 2 ले डिवाइड गर्दै छौं भनेपछि हामीले यो जुन चाहिँ लेफ्ट ह्यान्ड साइड नम्बर 1 छ यो चाहिँ हामी न्युमरेटरमा लेख्छौं अनि यो जुन चाहिँ लेफ्ट ह्यान्ड साइड नम्बर 2 छ यो चाहिँ हामी डिनोमिनेटरमा लेख्छौं. दैट इज dz by dx which is equal to राइट साइडमा के भयो त. सो अन द राइट ह्यान्ड साइड नम्बर 1 को राइट ह्यान्ड साइड हामी न्युमरेटरमा लेख्छौं. सो 1 upon it is 1 plus x square into 1 plus tan inverse x whole square, right? And in the denominator you should write down right hand side of number 2, that is 1 upon 1 plus x square. 1 upon 1 plus x square. Your right hand side number 2 को right hand side चाहिँ हामी denominator मा लेख्दै छौं. ठीक छ. So here 1 plus x 1 plus x 1 के भयो cancels. Here also dx gets cancels. So what do we get? So what is the value for dy by dz is equal to, it is 1 upon, this is 1 plus tan inverse x whole square. So this is the final answer. So what is the differential coefficient of tan inverse x upon 1 plus tan inverse x with respect to tan inverse x? It is 1 upon denominator 1 plus tan inverse x whole square. So that is your final answer. Okay. So we'll do the next question now. So now we'll do the next question, that is question number 11. So this is similar type of question as we have done in question number 10, right? So find the differential coefficient of first function, that is tan inverse within bracket root over 1 plus x square, root over under square root, there is only 1 plus x square, and minus 1 is not on the square root here, so minus 1 always whole divided by x with respect to tan inverse x. So you can use the same method as we have done in question number 10. Let us assume first function as y and the second function as z. That means you have to find out the differential coefficient of y with respect to z. That is, you have to find out dy by dz. Okay. So let y is equal to tan inverse within bracket root over 1 plus x square minus 1 whole divided by x, that is y, and what is z here? Z is equal to tan inverse x. Okay. So now let us find out dy by dx first. Therefore y is equal to tan inverse within bracket root over 1 plus x square minus 1 divided by x. Okay. So here also you cannot differentiate it directly because tan inverse, what is x here? Root over 1 plus x1 minus 1 whole divided by x. This is quite complicated expression is out there, isn't it? So you cannot differentiate it directly. Okay. So let us do the trigonometric substitution. Okay. So now in the numerator there is root over 1 plus x square. So I told you already that whenever you have root over 1 plus x square, what should be the trigonometric substitution for x? So either you can put x is equal to tan theta or it may be cot theta. So let us put here x is equal to tan theta. Why are you putting tan theta? Root over 1 plus tan square theta. 1 plus tan square theta, you know that it is sec square theta. What is root over sec square theta? It is sec theta. You may put cot theta also. If you put cot theta, 1 plus cot square theta, that is cosec square theta. What is root over cosec square theta? It is cosec theta. Is that clear? So let us put x is equal to tan theta. So let x is equal to tan theta. So get the value for theta here. What is the value for theta in this case? It is tan inverse x, right? So therefore y is equal to tan inverse within bracket root over it is 1 plus tan square theta minus 1 divided by it is, what is x? It is tan theta, right? So let us simplify it now. Or y is equal to tan inverse. So within bracket, what is root over 1 plus tan square theta? You know its formula from class 10. That is your sec theta, root over sec square theta. And what is root over sec square theta? It is sec theta. Then minus 1 divided by tan theta, right? So this is the simplified expression. But you should convert into sine and cos. Again, within bracket there is a fraction. You can simplify it by writing 1 by cos theta in terms of sec theta and sin theta by cos theta instead of tan theta. Okay? So therefore y is equal to tan inverse within bracket 1 upon cos theta minus 1 divided by what is tan theta here? It is sin theta by cos theta. Is it clear to all of you? So let us simplify it. Y is equal to tan inverse within bracket in the numerator. What's the LCM? It is cos theta, right? So here cos theta is the LCM. It is 1 minus cos theta divided by it is sin theta upon cos theta. So this is the simplified fraction. So here you can cancel this cos theta, cancel them. Or y is equal to tan inverse. Now within bracket you can write down the formula here. What is 1 minus cos theta from submolecular angle? You should know it. What is 1 minus cos theta? It is 2 sin square theta by 2. You know that. Divided by, in the denominator there is sin theta. You can use the formula of sin theta. What is that formula? It is 2 sin theta by 2 into cos theta by 2. Is it clear to all of you? So let's simplify it. 2 gets cancelled, sin theta by 2 and square gets cancels. So it is only sin theta by 2 upon cos theta by 2. What is it? It is tan, isn't it? Y is equal to tan inverse. So within bracket it is, what is sin by cos? It is tan theta by 2. Is that clear to all of you? So now you can easily simplify it. Now, or y is equal to, what is that? Tan inverse tan theta by 2? It is theta by 2, right? Tan inverse tan theta by 2 is theta by 2. Like, if there is tan inverse tan x, then you can write x. If it is tan inverse tan theta by 2, it is theta by 2. Now you should put the value for theta. So what was the value for theta there? It was tan inverse x was there, isn't it? Divided by 2. Now you can put the value for theta here. Okay? Now differentiate both the sides with respect to x. So this is the simplified form of this expression, that is tan inverse x by 2. So differentiating both the sides. So differentiating both the sides with respect to x. Therefore dy by dx is equal to there. Half is constant. You can write it before d by dx. Into what is d by dx of tan inverse x? It is 1 upon 1 plus x squared. Suppose this is equation number 1. So first function is differentiated. That means dy by dx is equal to half into 1 upon 1 plus x squared. Okay. The simplified form of tan inverse within bracket root over 1 plus x squared minus 1 whole divided by x is this one, tan inverse x by 2, right? So it will be easier for you to differentiate it, isn't it? So we get half into 1 upon 1 plus x squared after differentiating with respect to x. Okay. So next, what is the next one here? That is z is equal to tan inverse x. So again z is equal to tan inverse x. So you have to find out dz by dx here. So differentiating both the sides with respect to x. Okay, Therefore, dz by dx is equal to, so what is the differentiation of tan inverse x with respect to x? You can differentiate it directly. That is 1 upon 1 plus x square. Suppose this is equation number 2, right? But actually, we have to find out the value for dy by dz, because this first one expression was assumed as y, and the second expression, that is tan inverse x, was assumed as z. That means find the differential coefficient of y with respect to z. That is, you have to calculate dy by dz. Okay, so dividing 1 by 2. So dividing 1 by 2. So dividing 1 by 2, what do we get? Therefore, dy by dx divided by dz by dx, which is equal to, we are dividing 1 by 2. So write down left hand side of number 1 in the numerator, divided by, write down left hand side of number 2 in the denominator, is equal to. Now write down right hand side of number 1 in the numerator, that is half into 1 upon 1 plus x square divided by, now write down right hand side of number 2 in the denominator now. So what do we get? 1 upon 1 plus x square. Here this will be cancelled. Here dx is cancels, that is dy by dz is equal to, it is half. So this is the final answer. So this one is also important question. Okay, so you can copy it. And now we'll do the next question now. So now we'll do the next question, that is question number 13. Find the differential coefficient of the first function, that is x to the power sine inverse x is given with respect to sine inverse x. Here also you can use the same method as we have done it in question number 10 and 11. Okay, so number 12 will be a homework I'll give you. Okay, so let y is equal to x to the power sine inverse x and z is equal to what? Sine inverse x. Right? So let us find out dy by dx first. Now here given y is equal to x to the power sine inverse x. So you cannot directly differentiate here. You cannot find out directly dy by dx here, because both the bases and the powers are the variables here. You cannot differentiate it directly. You have to take log, because sine inverse x should be taken to the front of x. So you should take log on both the sides. Okay, so taking log on both the sides, taking log on both the sides. So what do we get? It is log y is equal to log x to the power sine inverse x, or log y is equal to, now you can use the properties of logarithm here. So because of this log, this sine inverse x becomes the coefficient of log x, that is sine inverse x into log x, right? So now you can easily differentiate it. So write down differentiating both the sides with respect to x. So we are differentiating both the sides with respect to x. What is the differentiation of log y with respect to x? It is 1 upon y into dy by dx is equal to. So which rule is used on the right hand side? You should use UV rule, right? So sine inverse x is kept as it is into, what is the differentiation of log x? 1 upon x. Now log x is kept same into, now differentiate sine inverse x with respect to x, it is 1 upon root over 1 minus x square, right? So we have got dy by dx. Now let us simplify it. Or 1 upon y into dy by dx is equal to, now let's take the LCM on the right hand side. So what's the LCM on the right hand side? It is x root under 1 minus x square, right? X root over 1 minus x square is the LCM. You know that, how to get the LCM, isn't it? Now this LCM is divided by this denominator x. X gets cancels. So now you should multiply that remaining term, that is root over 1 minus x square by sine inverse x. That is root over 1 minus x square into sine inverse x, right? Then plus sign is there. Again that LCM is divided by this factor root over 1 minus x square. That is root over 1 minus x square will be cancelled. So x remains out there. So x into log x is x log x. So x log x. Is it clear now? So now what is the value for dy by dx? Now cross multiply by y there is equal to y within bracket. Write down that fraction root over 1 minus x square sine inverse x plus x log x, this whole divided by what? X root over 1 minus x square. Here the bracket is closed. So I think you have understood it. Now put the value for y. What is y actually? It is x to the power sine inverse x. Now on the right hand side only you put the value for y. Okay. So or dy by dx is equal to, what was the value for y? It is x to the power sine inverse x. X to the power sine inverse x within bracket root over 1 minus x square sine inverse x plus x log x. This whole divided by what should you write? X root over 1 minus x square. Suppose this is your number 1. So y is equal to x to the power sine inverse x is differentiated. And we got the value for dy by dx here, and suppose it is marked number 1. Okay. So now we have to find out dz by dx now. So again, here what is z? Z is equal to sine inverse x, right? So this is the simplest function to be differentiated, isn't it? Now differentiating both the sides with respect to x, so therefore dz by dx is equal to, now you can easily differentiate it, isn't it? Just use the formula. What is d by dx of sine inverse x? It is 1 upon root over 1 minus x square. Okay, so this is number 2. So actually in this case, what is to be determined? Find the differential coefficient of y with respect to z. That means you have to find out dy by dz. Again you have to divide. Divide 1 by 2 to get dy by dz. So dividing 1 by 2. The 1 and 2 let divide also. The question is here. Write down left hand side of number 1 in the numerator, that is dy by dx, divided by, write down left hand side of number 2 in the denominator. Dz by dx is equal to, now on the right hand side what will be there? Write down right hand side of number 1 in the numerator, that is x to the power sine inverse x within bracket root over 1 minus x square, this is sine inverse x, then next plus x log x, this whole divided by x root over 1 minus x square. This is the right hand side of number 1 divided by, now in the denominator what will you write? You write down right hand side of number 2 in the denominator, 1 upon root over 1 minus x square. So I think you have understood it. So here you can cancel this, root over 1 minus x square, root over 1 minus x square will be cancelled. So here also dx will be cancelled. So what is the final answer? What is the final answer, or what is the final value for dy by dz? Here dx will be cancelled. So dy by dz, you have to get this value. That will be the answer. What is dy by dz? It is x to the power sine inverse x within bracket. So what do we get? Root over 1 minus x square. It is sine inverse x. Then plus x log x is there, isn't it? So whole divided by x. This is whole divided by x. Is that clear to all of you? So this is your final answer. So this is also important question. So you can copy it. So we'll do the next question now. So now we will do the next question, that is question number 14. So here given is, if y is equal to x upon root over 1 plus x square, it is given. You have to prove that x cube dy by dx is equal to y cube. That means you have to prove you have to prove LHS is equal to RHS. So first of all, you get the value for dy by dx from given, and you prove LHS is equal to RHS. Okay. So now here given is y is equal to x upon root over 1 plus x square, right? So let us differentiate it. Differentiating both the sides with respect to x, alright? So therefore dy by dx is equal to, which rule is used? U by v rule. You know that, isn't it? U by v rule or quotient rule. So now let us keep the denominator as it is in the numerator, root over 1 plus x square into, what is dy dx of x? That is numerator, it is 1 minus, is that clear? Now numerator is kept as it is into, now take the differentiation of the denominator and write it in the numerator. That is, what is the differentiation of this root over? It is 1 by, you know that, 2 root over 1 plus x square into, now this 1 plus x square was assumed as x and we have differentiated it. That is 1 by 2 root over x. Again you have to differentiate the term which is assumed as x. That is, you have to differentiate 1 plus x square with respect to x. What is it? For 1 it is 0 and plus x square it is 2x. That is 0 plus 2x is always 2x. Is that clear? So whole divided by, what is denominator whole square? That is root over 1 plus x square whole square. So this is the u by v rule. So this is differentiation of u upon v rule. Okay. So now let us simplify it. Here 2 gets cancels. Or it is dy by dx is equal to, now in the numerator, what's the LCM here now? It is root over 1 plus x square is the LCM. So below it, it is 1. Now this LCM is divided by 1. So it is root over 1 plus x square. Root over 1 plus x square into root over 1 plus x square. That is 1 plus x square, right? Then minus sign. Again, this LCM is divided by root over 1 plus x square. It goes one time. So 1 into this x into x is x square minus x square, right? So here it is in the denominator, you can write root over 1 plus x square, this is whole square. Okay? So now here this x square gets cancels, or what is the value for dy by dx? So it is dy by dx is equal to, in the numerator we have 1 upon root over 1 plus x square into now below denominator there is 1 again. So in the numerator it is 1 upon root over 1 plus x square. When this denominator goes up in the numerator, it becomes upside down. ठीक उल्टा हुन्छ माथि जाँदाखेरि. त कति भयो? 1 upon root over 1 plus x square. So I think you have understood it. Or what is the value for it is 1 upon, it is root over this whole square, isn't it? That is within square root 1 plus x square, whole square is there. So when it becomes upside down, 1 upon in the denominator root over 1 plus x square whole square, right? Or what is the value for dy by dx now? It is dy by dx is equal to 1 upon, you can multiply these two root over, powers will be added. So what do we get? Root over 1 plus x square whole cube. Okay? So we have got the value for dy by dx. Is it clear now? Now let us prove LHS is equal to RHS, right? So LHS is equal to, what is LHS? X cube into dy by dx, right? Is equal to x cube into, what is the value for dy by dx? It is 1 upon, it is root over 1 plus x square whole cube is equal to, so x cube into 1 is x cube divided by, in the denominator it is root over 1 plus x square whole cube. Is that clear now? X cube into 1 is x cube divided by, within root 1 plus x square whole cube. This is your left hand side. Now let us find out the right hand side now. So what is right hand side here? You should prove LHS is equal to RHS here. Okay? So what is RHS in this case? Y cube. You can put the value for y from given x upon root over 1 plus x square whole cube. Right? So now this power 3 is for both numerator as well as denominator. You have to write down power 3 for both numerator and denominator. So what do we get? That is x cube divided by root over 1 plus x square whole cube. So are they equal, LHS and RHS? So what is LHS here? X cube upon root over 1 plus x square whole cube. Also right hand side is also x cube divided by root over 1 plus x square whole cube. That means we have proved LHS is equal to RHS. So let us write here LHS is equal to RHS. So it is proved. Understood? So you can prove it like this also. So in this case, we have got the value for dy by dx from given, and you put it on the left hand side and on the right hand side and prove LHS is equal to RHS. Okay? So you get the value for both left hand side as well as right hand side and prove LHS is equal to RHS. Okay? Now we'll do the next problem now. So now we'll do the next question, that is 15 number 3. This is also important question because this question is from HS question paper, right? That is 15 number 3. So if root under 1 minus x square plus root over 1 minus y square is equal to a into x minus y. Here x and y are the variables and a is a constant here. You have to prove that dy by dx is equal to within square root 1 minus y square upon within square root 1 minus x square. Okay? So given is this one, and you have to prove the value for dy by dx is equal to this one. Okay? So let us write on given. So you have to prove it from given root over 1 minus x square plus root over 1 minus y square is equal to a into x minus y. So in this case, let's do the trigonometric substitution, because if you use trigonometric substitution, it will be easier for you to simplify it and then prove the value for dy by dx. Okay? If there is root over 1 minus x square, what should you put for x? X may be sine or x may be cos. Let us put sine. So let x is equal to, let us put here sine A, and since y is the other variable, x and y are the two different variables, let us assume y is equal to sine B. If we assume x is equal to sine A, don't assume y is equal to cos B. Same trigonometric function should be there. If x is equal to cos A, then y should be cos B. But if it is x, but in this case we are putting x is equal to sine A, so y is equal to sine B should be there. Okay? So get the value for A. What is A is equal to? Sine inverse x. And what is the value for B here? It is sine inverse y. Is it clear to all of you? Now let us put the value for x and y in given. Therefore, now the given becomes root over 1 minus, what is x square here? Sine square A plus root over, it is 1 minus sine square B is equal to, on the right hand side, let us put A into, what is x out here? It is sine A. It is sine A minus what? What is y? It is sine B. So is that clear now? Next, what is root over 1 minus sine square A? You know that the formula is cos A plus cos B is equal to A into, within bracket, it is sine A minus sine B. So now you should know the formula from transformation of products and sums in trigonometry. This is just like your cos C plus cos D, but this is sine C minus sine D. So let us use the formula now. Okay? What is cos A plus cos B? 2 cos of C plus D. That is A plus B by 2 into cos C minus D by 2. What is cos C minus D by 2? Cos of A minus B by 2. Is that clear? So next is equal to A into what is sine C minus sine D out here? What is sine C minus sine D? 2 cos C plus D by 2. 2 cos C plus D by 2. What is C plus D by 2? A plus B by 2. That is 2 cos C plus D by 2. Then sine of C minus D by 2. That is A minus B by 2. Is that clear to all of you? That is, what is sin C minus sin D? 2 cos C plus D by 2 into sin C minus D by 2. So from both the sides you can cancel. These 2 gets cancels. And also cos of A plus B by 2 gets cancels. So remaining terms are cos of A minus B by 2 is equal to A into what? Sine of A minus B by 2. Is it clear to all of you? So since cos of A minus B and sin of A minus B by 2 same angle is there, let us take that sine to the left hand side. So it is A into sine. So when this sine goes to the left hand side, you should write it in the denominator. So or it is cos of A minus B by 2 divided by sine of, this is A minus B by 2, which is equal to what? It is A, right? So is it understood now? Next, so now in the next step, what is cos by sine? It is cot of A minus B by 2 is equal to A, right? Cot take to the right hand side. A minus B by 2 is equal to cot inverse A. Now let us do cross multiplication. A minus B is equal to 2 cot inverse A. So this 2 cot inverse A is a constant term, right? So let us put the value for capital A. What is capital A actually? Actually we have taken x is equal to sine A. What is A is equal to? Sine inverse x, isn't it? This is your sine inverse x minus, what was B actually? It is sine inverse y. Because we have taken y is equal to sine B. And what is B is equal to sine inverse y. So which is equal to 2 cot inverse A. Again you have to express A in terms of x and B in terms of y. Now you can differentiate it. Now differentiating both the sides with respect to x. So differentiating both the sides. So differentiating both the sides with respect to x. So what do we get? Differentiating both the sides with respect to x. What do we get? What is the differentiation of sine inverse x with respect to x? 1 upon root over 1 minus x square. Then minus sign is there. What is the differentiation of sine inverse y with respect to x? So first of all, you should take it as sine inverse x. What is the differentiation of sine inverse x again? 1 upon root over 1 minus y square. But here, instead of x, there is y. Again, you have to differentiate the term which is assumed as x. That is, y was assumed as x. Now differentiate y with respect to x into, it is dy by dx is equal to, what is the differentiation of 2 cot inverse A? This is constant term which is free from x and y. This 2 cot inverse A is free from x and y. So this is a constant term. So its differentiation is always 0. So now you can easily get the value for dy by dx from here. So let us take this 1 by root over 1 minus x square to the right hand side. Or minus 1 upon root over 1 minus y square into dy by dx is equal to what? 1 upon root over 1 minus, take it to the right hand side, minus 1 upon root over 1 minus x square, right? So here minus minus gets cancels. So what is the value for dy by dx? So dy by dx is, now this is into, so cross multiply by root over 1 minus y square and write it in the numerator. So root over 1 minus y square into 1 is root over 1 minus y square divided by what? It is root over 1 minus x square. So we have proved the given result. So it is proved. Okay. So this is very important question, and this is from your HS question paper also. Okay. So you can revise it. You can copy it now. Let's do the next problem now. So now We'll do the next question, that is question number 16. If y is equal to e to the power sin inverse x and z is equal to e to the power minus cos inverse x, then prove that the value of dy by dz is independent of x. That means the value of dy by dz should be free from x. There should not be no term containing x while you get the value for dy by dz. Now, these y and z are expressed in terms of a third variable x, that is x is a parameter here, so this is also a parametric equation. So you know how to differentiate this parametric equation. That means how can you calculate dy by dz, that you know it, isn't it? So let's do the solution now. So what is the first given one here? Y is equal to e to the power sin inverse x. Because no need of taking log on both the sides here, because you know that e is the exponential function, you can take it as e to the power x, isn't it? So let us differentiate it. So I am differentiating both the sides. Differentiating both the sides with respect to x. You know how to differentiate it. So dy by dx is equal to, first of all, it is e to the power x form. What is the differentiation of e to the power x? It is e to the power x. What you have to write in the power sin inverse x into, again differentiate the term which is assumed as x. That is, sin inverse x was assumed as x. Now let us differentiate sin inverse x with respect to x. What is it? 1 upon root over 1 minus x squared. So let us mark it number 1. Is it clear? So again what is z is equal to here? Z is equal to e to the power minus cos inverse x, right? So let us differentiate both the sides with respect to x now. So differentiating both the sides with respect to x. So what do we get? Therefore dz by dx. Therefore dz by dx is equal to, again e to the power x form is there. What is the differentiation of e to the power x? E to the power x, but here x is minus cos inverse x. Again you have to differentiate the term which is assumed as x. So in this case, minus cos inverse x was assumed as x. Now we have to differentiate it. So what is d by dx of minus cos inverse x? It is cos inverse x for differentiation minus. So minus over minus plus. So it is 1 upon root over 1 minus x square. Because minus sign is already there. Again the differentiation of cos inverse is negative. So negative is positive. So 1 upon root over 1 minus x square. So let us mark it number 2. Now what is to be determined? You have to find out the value for dy by dz. That means dividing 1 by 2. So dividing 1 by 2, what do we get? Dividing 1 by 2. So what do we get? dy by dx divided by dz by dx is equal to. So now put the value of dy by dx in the numerator, that is e to the power sin inverse x into 1 upon root over 1 minus x square. This whole divided by, now we have to write down right answer of number 2 in the denominator. Okay, so it is e to the power minus cos inverse x into 1 upon root over 1 minus x square. Is it clear now? So now let us simplify it. So here dx will be cancelled. So you will get dy by dz. That means we are getting the value for this dy by dz. So here you can cancel 1 upon root over 1 minus x square, right? So e to the power. Now you can simplify the powers of e. So when this e to the power minus cos inverse x goes to the numerator, it becomes plus. And you can simplify it with e to the power sin inverse x plus cos inverse x. Is it clear to all of you? So you know the formula sin inverse x plus cos inverse x from inverse circular function. We did it, isn't it? What is the formula for sin inverse x plus cos inverse x? It is pi by 2. So or dy by dz is equal to e to the power pi by 2. That means this is the term which is free from x. That is, the value for dy by dz is independent of x because there is no term containing x in the answer. So what can you write here? Hence the value of dy by dz is independent of what? it is independent of x. Proved. Hence the value of dy by dz is independent of x. So I think you have understood it. So you can copy it. We'll do the next question now. So now we are doing the next question, that is question number 17. If y is equal to sine within bracket pi by 6 e to the power xy, then you have to find out dy by dx at x is equal to 0. So here x is equal to 0 is given, but the value for y is not given. So before you get the value for dy by dx, let us get the value for y from given when x is equal to 0. Okay. So here given is y is equal to sine of, this is pi by 6 e to the power xy. Okay. Since x is equal to 0 is given, but the value for y is not given, you have to find it yourself. Y value. So you put x is equal to 0. So putting x is equal to 0 now. So what do we get? Y is equal to sine within bracket pi by 6 e to the power x is equal to 0. 0 into y. What is 0 into y? 0. That means e to the power 0 is here. Or y is equal to, this is sine pi by 6 only, because e to the power 0 is always 1. Something to the power 0 is defined as 1. So it is only pi by 6. So it is sine 30 degrees, isn't it? So y is equal to, what is it? Sine pi by 6 means 180 by 6, that is 30 degree. What is the value for sine 30 degree? It is always half. That means y is equal to what here? Half. So now we have to take x is equal to 0 and y is equal to half. Now let us differentiate the given function. So here given is, what is given again? Y is equal to sine of, it is pi by 6 e to the power xy. Now how can you differentiate it? You have to differentiate it directly. Find out dy by dx. You should take it as sine x. Which function is taken as x? Pi by 6 e to the power xy. Okay, so I am differentiating both the sides with respect to x. Differentiating both the sides with respect to x, right? So it is dy by dx is equal to sine x form. What is the differentiation of sine x? Cos x. So it is cos of within bracket pi by 6 e to the power xy. That is your cos x. Again, you have to differentiate the function which is assumed as x. In this case, which function was assumed as x? It is pi by 6 e to the power xy. Again, you have to differentiate it. That is, pi by 6 is constant, it is kept as it is, into what is d by dx of e to the power xy. Now it is just like your sin x, isn't it? What is the differentiation of sin x? It is cos x. But what is x here? Pi by 6 e to the power xy. Again, you have to differentiate the term which is assumed as x. That is, pi by 6 e to the power xy was assumed as x. And pi by 6 e to the power xy is also to be differentiated. You should differentiate pi by 6 e to the power xy. So what is this differentiation now? Pi by 6 remains same because it is constant. Now differentiate e to the power xy. What is the differentiation of e to the power xy? E to the power xy. Again, this xy is taken as x and it was differentiated, isn't it? So e to the power xy. Is that clear? Now again differentiate the term which is assumed as x. Now xy was assumed as x. Now differentiate xy into, what is this differentiation? Xy differentiation, product rule. So x into dy by dx, right? X is kept as it is, and differentiate y with respect to x, that is dy by dx, plus y is kept as it is into, now differentiate x with respect to x, that is 1. Second bracket is closed, then third bracket is also closed. Is it clear now? Now don't simplify it, just put the values of x and y. You will get the simplified answer here. Okay? So, or dy by dx is equal to cos of within bracket pi by 6 e to the power. So x is 0 here. What is 0 into y? that is 0. You don't have to put the value for y out here. Within third bracket, pi by 6 into again e to the power 0 into y. Here also you don't have to put the value for y. What is 0 into any number? 0. Now within second bracket, right? What is the value for x in this case? It is 0. 0 into dy by dx. It is 0 into dy by dx. Okay? So I think you have understood it. Let's just put in the values. Plus y ones are y. What is the value for y? You have to put the value for y here. So y is equal to how much is it? It is half. It is half. Second bracket closed. Then third bracket is also closed. I think you have understood it. So let us simplify it. So therefore dy by dx is equal to, now it is cos. What is e to the power 0? Always 1. Something to the power 0 is always 1. So it is pi by 6. Write down here pi by 6. Right? And within third bracket here we have pi by 6 into e to the power 0 is 1. Within second bracket, 0 into any number is always 0 plus, and it is half. First bracket closed, third bracket closed, right? Or what is the value for dy by dx now? So dy by dx is equal to, now it is cos 30 degree. What is cos 30 degree? Cos 30 degree is root 3 by 2, isn't it? Sin 30 is half, but cos 30 is root 3 by 2. And within third bracket, what is it? Pi by 6 into, what is 0 plus half? It is half. Third bracket is closed. Or, what is the value for dy by dx now? Dy by dx is equal to root over 3 divided by, this is 6 2s are 12, 12 2s are 24. Then you have to write down pi. So, this is the final answer. So, what is the value for dy by dx at x is equal to 0 and y is equal to half? It is dy by dx is root over 3 pi divided by 24. So, this is the final answer. So, this is quite complicated problem. So, you revise it at home. It will be easier for you to do the problem. Okay. So, now I'll give you the homework. So now, these are your homework. From the same exercise 3, each question carries 4 marks, page number 293. That is, your homework is question number 12. Find the differential coefficient of cos inverse within bracket 1 minus x square upon 1 plus x square with respect to sin inverse 2x upon 1 plus x square. You know that, how to do it, isn't it? So you can do it at home, right? And 15 number 1 is, if y is equal to e to the power y by x, prove that dy by dx is equal to y square upon x into y minus x. So you can prove it, you can try it yourself. So if you can't do it, you can tell me, okay? So 15 number 2, if y e to the power y is equal to x, prove that dy by dx is equal to y upon x into 1 plus y. I think you can do it. First you try it. If you can't do it, then you can comment me or you can ask me to do it, okay? So I'll do it for you if you can't do it, okay? So I think you can do it. You must do it, okay? So this much is for today. So in the next online class, we will do more problems, okay? So till then, goodbye, thank you.